So today we are going to do differential equations. These are very kind of straightforward and boring. I think of it like the U substitution. Do you remember how it was like you do this step, this step, this step, this step, there's your answer? There's not a whole lot of what does it all mean. So if you're very much like, here, let me just do these math problems, this is, kind of your thing. What you're given is dy dx, which means what? Derivative. And the idea is you want the original function, which means you're going to have to take a antiderivative. We're going to go backwards. So the first one, I just made it so you could sort of just write the answer. It's not complicated at all. So if this is your derivative, dy dx, what would be your antiderivative? We want to go backwards to the original function. All right, 2x squared plus 3x. Now, this is what's called an initial condition, which we've talked about before. It means if you plug in 0, you should get 5. So at the end, I'm going to have to put plus 5. Did everyone follow me there? So this is your initial condition. If you plug in 0 to your equation, you should get 5 as your output. We're given the derivative. We want the original function, which means we have to do an antiderivative. No, and I'm getting to that. Can you just hold on? I will explain why, okay? But we need some steps. So here are your steps. Number 1, you're going to separate your variables. Everything with a y is going to go to the left. Everything with an x is going to go to the right. Hey, Miss Cole, if I do it the other way around, can I still get the answer? No. Y goes to the left, x goes to the right. You want your answer to be y equals. Think you want y over here, x over here. So you're reading left to right. Does that make sense? That's actually why it has to stay dy dx, or you can't separate the y from the x. If you write it as f prime, you don't have a y and an x anymore. Okay? Correct. All right. Then you're going to integrate, which means antiderivative. You're going to take an antiderivative. And then you're going to put plus c. It's so important, I give it its own step. If you don't write plus c, and there will be one of these on the free response of the AP exam, they always put one on there. If you don't write plus c, you're out the points for the rest of the problem. They won't even probably read it any further if you forget to put plus c. Even if you correct, well, I guess if you correct it later on and they see a plus c somewhere, they might hang in there with you, but it is super important. All right, then you're going to use your initial condition. If there is one. If there's not, then just skip that step. All right, so if they don't give you an initial condition, please don't invent one. Just don't do step 4. All right, and usually that all goes well. The last step is where people fall apart. You're going to solve for y, which means algebra. And it is never the calculus that is the problem. It is always the algebra. That step 5 is the killer, because sometimes they get pretty complicated. Now, hey, Ms. Cole, you said that this step was optional. Sometimes they give you one and sometimes they don't. If they don't give you an initial condition, what you're finding is the general solution. So you're in general solution. You're going to leave your plus c in there, and c could be anything, right? So since c could be anything in the entire world, that is infinite solutions. So you get infinite number of answers, which I think is actually pretty cool. You're going to get an infinite number of answers. Good. Correct. So you're just going to leave plus c in there. And if you have an initial condition, what you're finding is the particular, can't talk and write at the same time, particular solution, which means only one. That one particular solution for that initial condition. So specifically for that initial condition, you only get one single answer. And so you won't have C anymore. You'll figure out what C equals. Like the one that I just had you do right here. C is 5. How many answers did we get? 1. We got this one answer. If I didn't give you the initial condition, instead it would say plus C. And C could be anything in the world, so it would be infinite solutions. Are you understanding the difference? I hit that pretty hard because next class we're doing slope fields, and you've got to understand do you remember slope fields at all from last year? Okay, cool. Those little they look like magnetic fields. They're not, but you know. You what? Oh, well, I will fix that. It will be okay.
So is this essentially like the opposite?
We are doing, yes, it's the opposite. You're just going backwards.
Okay, so it's like exactly.
But they can get complicated.
Okay.
There's like actually, if you go to college, there's a whole class called differential equations that you can choose to take if you want to. So they can get complicated. But these are your steps. So just remember your steps, and here we go. We're just going to practice a whole bunch of them, all right? So for this one, we want everything with a y to go to the left. I am going to multiply this 3y squared to the other side. So if I multiply that over, I'm going to have 3y squared dy equals, and then I'm going to multiply this dx to the other side. So I'm going to have 1 dx. And I'm going to use a different color to put my integral symbols on there just to show like how important they are. So we did separate. We separated. Everything with a y went to the left, x went to the right. Now we're going to integrate. So what is your antiderivative for 3y squared? Y cubed equals, and then your antiderivative for 1 dx. This side is x. So just x plus c. That was steps 2 and 3. I make plus c its own step because it is so important. Now, step 4 is if you have an initial condition. Do you see an initial condition written here? No. So just skip that. And we're going to solve for y. How do you undo a cubed? Cube root. So it is cube root of x plus c. As a side note, 2 things. 3 is an odd number. But pretend it was an even number. Say we did a 4th root or a square root or an 8th root. The even ones get a plus minus, which is really important. Okay, the odd ones don't, but the even ones get a plus minus. And the other thing I was going to say was, instead of cube root, you could also write this as x plus c to what power? 1/3. And the reason I bring that up is if it was multiple choice, and it was written this way instead of that way, I'd still want you to be able to get the right answer. This is a general. Why is it a general solution? We did not have an initial condition. We left plus c in there. So c could be 2 or negative 12 or 46 or 0. So that's why there's an infinite number of answers. Got it?
So if it's just general, then you don't have to include the plus minus.
You would need a plus minus.
Oh, so
if it is a general answer, you need the plus minus because you want to take care of an infinite number of answers. If it's one particular answer, you choose whether you want the plus or do I want the minus. And I'm going to show you how to do that. Okay. All right, for this one, we're going to separate. I'm going to multiply the 4y to the left side. So we're going to have 4y dy equals, and then I'm going to multiply the dx to the right side. So 3x to the 5th plus 1 dx. So that is separating. And then we're going to integrate. So your antiderivative. So antiderivative of 4y is 2y squared. Perfect. Equals, now ignore the 3 for a second. You would want it to be 1/6 x to the 6th. But since there's a 3 there, it would be 3/6, which is 1/2. Good. 1/2 x to the 6th plus x plus c. Now hold on, it's more complicated than that. You can't just slap a -2 at the end. All right. It might work out that way. No, it's not. Okay. If we plug in 0 for x and -2 for y, then we can solve for c. I made that number 1 just super easy so you could do it in your heads and we could understand like what the concept was, but these are going to be more complicated than that. So we're going to plug in 0 for x, which means all of these are going to go away and it's going to just be c. And we're going to plug in -2 for y. So -2 squared, 4 times 2, 8. I always draw an arrow when I do this. It's another one of those silly little things that over the years I have found helps. You're going to go back to this step, the previous one, and you're going to copy it literally exactly, except instead of plus c, you're going to put plus 8. Copy it exactly, except put plus 8. Usually right there I get asked, or I know half of you are thinking this, Can't I just erase this C and put an 8? You thought it, didn't you? Don't do that, because on the free response part of the AP exam, you just got rid of one of your steps that they're going to give you a point for. Do you get what I'm saying? You just erased one of the things that was worth a point. So don't do that. You have to rewrite it, okay? Now we have 2 steps of algebra. How do I get rid of this 2 that's out front? Here's what I want you to do. The less writing you do, the less likely it is you will make a copy error, and these can get complicated. So here's what I want you to do. I want you to scratch it out and take this whole thing and just divide it by 2. Be lazy on this step, because the more times you rewrite it, the more likely it is you'll do a copy error. Right? Now, this is going to answer the question you had. See how this is squared? To get rid of a squared, we're going to do square root. Now, this is a particular solution, so we're not going to put plus minus. We're going to choose, do we want the plus or do we want the minus? And it always comes from this output value on your initial condition. Do you see how our output value is negative? We need our result to be negative. So we want the negative square root. So it's going to be negative square root of this whole mess. So that is how you tell whether you want the plus or whether you want the minus. And again, that's only for the even roots. For the odd roots, they don't get that. So you just don't even worry about it. Okay, I'm not being bombarded with questions anymore. So it seems like we're all on the same page. Okay, try another one. I'm going to move this y to the 4th to the other side, but I'm not multiplying it this time. This time I am dividing it. So it would look like this. But I don't want to write it that way. I want to write it as y to what power? Yes, negative 4 dy equals 4x, and I'm going to multiply the dx over, so dx. Usually there I get asked, hey, Ms. Cole, why didn't you move the 4 over? It's a personal preference kind of thing, but the less stuff you move over to the left, the less stuff you're going to have to just move back over to the right in the end. You know, your last step is to get y alone. So the less garbage you have over there, the less work you're going to have at the end. Go ahead. I'm moving the y to the 4th to the, remember, everything with a y goes to the left. So I'm moving that to the left side by dividing. Okay? So now antiderivative, be careful because it's negative. When I add 1 to the power, it's going to become what? Negative 3. And so in front, I need a negative 1/3 equals 2x squared plus c. Cool. Now I'm going to take a step and rewrite this so that I don't have a negative power. In fact, if you want to erase this one, you can, because we're not actually doing a step. We're just going to kind of rewrite this. I'm going to write this as negative 1 over 3y cubed, so that when I go and plug in, I don't have a negative exponent. But I didn't erase a step of my work. I just got rid of the negative exponent. So we have an initial condition. We're going to plug in 0 for x and negative 1 for y. So if I plug in 0 for x, this stuff's all just gone. If I plug in negative 1 for y, all right, let's see. Negative 1 cubed. Negative 1 times 3 is negative 3. So you have negative 1 over negative 3, which is just 1/3. So we're going to go back to this step, the previous one, and we're going to recopy it exactly like it looks, except instead of plus c, we're going to put plus 1/3. You just recopy it exactly. And I ran out of room, so I'm going to have to come up here. I want everybody to watch me point to this, because this is the easiest way to do this. Mathematically, what's going to happen next is you're going to take this y to the 3rd and multiply it over here. And then you're going to take all of this stuff and divide it over here. So those 2 items are just going to switch places. Is that making sense? Okay, I'm going to multiply the y to the 3rd over here, and I'm going to divide all of this stuff over to there. So they're just going to switch places. It's going to look like this. And I'm not going to read the whole thing to you because that would be really annoying. It's just all of that stuff and then equals y cubed. So those items just switched places is all that happened. And then unfortunately, yes, you do have one more step to get rid of the cube root. Now, does that need a plus or a minus? No, because it's odd. We'll do one more and then I'll give you a brain break because I think we're doing okay on time. So look through number 5. What do you notice about it? Because it's actually a little bit different. There's not a y at all. So all we're going to do to separate is multiply the dx over. Here's my suggestion. When that happens, I put a 1 in front of the dy. I do think that that helps. So stick a 1 in there, and then you're just going to multiply the dx over. Yes, and why is that really good? Like, why is that helpful to us? Yeah, you don't have to do any algebra. Your goal is to get y by itself. Nice when that. Correct. But what is the antiderivative of this? If you can't just write the answer, you need to go back to the tools you have in your toolbox. It's going to be one of those other methods of integration, which is going to be what in this case? How are we going to do an antiderivative? You can think about it while I'm fighting with my projector here. Antiderivative. Oh, I heard somebody say it. U substitution. Okay. You don't have to actually know what it's called as long as you can like work through and get an answer. Why are you reconnecting? Please work. Trying to do my job. There we go. All right, what are we going to let u equal for this one? X cubed plus 4. Du would be 3x squared dx. Now you go on a search for that. I have the x squared dx, but I need to turn a 3 into a 5. You would multiply by 5 over 3. So this is going to be y equals, which is really good, because after I do this, then we'll be finished. When you go and substitute in, 5/3 goes out front, du goes at the end. I kind of ran out of space here because I wrote too big on the other problem. But what is still there that we did not substitute out yet? 1 over u. So what is your antiderivative? I'm going to write my answer down here where I have a little bit more space. What's your antiderivative of 1 over u? ln, and what do you need? Absolute value, and what was u? The x cubed plus 4, and then at the end, plus c. And why are we done? Thank goodness, because I ran out of space. It's general. There's no initial condition. So you have an infinite number of answers because c could be anything in the world. Cool. All right, for this one, again, do you see how there's not even a y in the problem? Yeah. Okay, so we're going to put a 1 in front of the dy. I do feel that that helps. And all you really need to do is multiply the dx to the other side. And so again, what's really nice about that is when you do your antiderivative on the left side, you're going to just get y all by itself, which is the goal in the end anyway, so it ends up being less work. Now, this one's also going to be a u substitution. But in this case, I would not write it all out like we did on the other one. You would let u equal what? 5x, and so you're just going to adjust it with a 1/5. Just slap a 1/5 in front and move on. I would not write out all the steps, okay? Because this exam you're going to take is time. So y equals, we're going to slap a 1/5 in front of it, and what's your antiderivative of cosine? And let everybody think. You need to think of a trig function that if you did the derivative, you would get cosine. Sine, good job. So sine 5x, and then at the end, plus c, good job. The derivative of sine is cosine. We did not need a negative. That's it. Yeah. All right, in number 7, what do you notice is something that we don't like how it's written? We would want to write it a different way. Y prime. I cannot stand when they do this. You can't separate the y and the x if it's not written as dy dx. So the very first thing I'm going to do, and I'm just going to kind of slide this up here, is I'm going to rewrite the whole thing, but instead of y prime, I'm going to put dy dx. Or if you're able to hold that in your imagination, you don't need to rewrite the whole thing, but I'm doing the problem in front of everyone, so I like to write all of it. All right, so what would we do to get dy dx by itself? You would divide by all of this, and then you would hopefully notice, hey, there's not a y in the problem. So then you would also multiply over the dx. Okay, so we're going to have 1 dy equals x divided by all that stuff, and then dx. You guys are at a level where I could talk you through that. We don't have to write out every single tiny little step. All right. Antiderivative. So once again, what's nice about this is you're going to just have y equals. What's going to cause this one to be a little bit more work is two things. First is I can't just write the answer to this. I don't just know what the antiderivative is. So it's again going to be a u substitution. All right. And then what's the other thing that's going to make it be a little bit more work? You have to actually plug in your initial condition. We're going to get a particular solution, just one answer. All right. What are we going to let u equal? We have to actually write it out. This one's more complicated. Can I write x squared plus 3 instead of 3 plus x squared? Is that okay? Sorry, that's just, is anybody else like a little OCD like that? Sometimes? I guess it depends on the day. All right, so what is your derivative of that? Yeah, 2x dx. I don't see a 2 in the problem, so we're going to need a 1/2. Good job. I'm waiting. Oh, okay. If I do need to wait, let me know. So 1/2 is going to go out front. Du goes at the end, and we have to figure out what's still there that we didn't substitute yet. We took care of the x and the dx. Like all of this we took care of, the x and the dx. All right. So what's still there is square root of u, but it's in the denominator. So instead of u to the 1/2, because 1/2 would be a square root, it's actually u to the negative 1/2, which is going to be okay. It's going to be okay. So now we're going to do that antiderivative. This 1/2 kind of just sits there. You're going to add 1 to the power, which is good because it won't be negative anymore. Negative 1/2 plus 1 is positive 1/2. And so in front of that, you need a 2, which is actually also good because, yeah, they cancel out. And then at the end, we need plus c. All right, nearly there. Y equals 1/2 means square root, and what was u? X squared plus 3 plus c. Last thing we're going to have to do is figure out what c equals. You're going to use your initial condition. All right, so what was our initial condition? At this point, I'm like, what's... we're going to plug in 1 for x. It's not always 0. 1 for x and 14 for y. So let's see. 1 squared is 1, plus 3, 4, and then square root of 4 is 2, plus c. So what does c equal? 12. So we're going to recopy this step, except instead of plus c, we're going to put plus 12. Can't draw my 3s today. And then we're done because y is already alone. If y was not alone, then you would have to do the algebra to solve for y. Okay? These last 3 are all really similar. I put them on there so you could kind of compare and contrast. What would you do to separate this one? How would you get y to the left side? Divide. Now, to compare, do you know how this one, we wrote it as y to the negative 4? Remember this? It wasn't that long ago. Okay? We don't need to do that here. We're just going to write 1 over y. Because what would that antiderivative be? Just foreshadowing. It's going to be ln. But it only works for 1 over y. If you have 1 over y squared, or 1 over y cubed, or 1 over y to the 4th, you have to write it with the negative exponent. All right? That's the only pattern that gives you ln. All right, equals, and then what's going to be on the other side? Yeah, x squared dx. Perfect. Antiderivative. We just said this one's ln. And then what is your antiderivative for x squared? 1/3 x cubed, perfect, plus c. All right, cool. Is there an initial condition? No, so skip that. We're going to solve for y. All right, on this problem, I'm going to write out every single last little step, and then on 9 and 10, I'm going to kind of talk you through it. You don't have to write it all every single time, all right? How would you cancel out ln? E, okay? It's technically called exponentiating, but everyone says we're going to e the problem. I'm like, all right, fine, whatever. All right, so it's going to be e to the power of all this stuff. Now, when you multiply, you add your exponents. So what we're going to do is write it as e to the 1/3 x cubed times e to the c. It comes back to algebra 1, your exponent rules. When you multiply, you add your exponents. When you divide, you subtract your exponents. All right, we talk about those with logarithms as well. Now, you're correct. Let me get everybody else there. E is a number. It's about how much? 2.7-ish, okay? C is also a number. It's just a value. So this whole thing is just a number, all right? And we're going to write it out front. E is a number, C is a number, so e to the power c is just a number. So we just call the whole thing c, and we put it out front so that it's a coefficient. Last step is to, let me finish the problem real quick. The last step is to get rid of the absolute value. When you get rid of an absolute value, you put plus and minus. The reason why is an absolute value is a distance from 0. Give me a single digit number for us to talk about. 8, all right? How can you be 8 units away from 0? Pretend I'm standing on 0. You could be at 8 or you could be at -8, all right? So an absolute value is a distance from 0. To get rid of that, you put plus minus. If it was a particular solution, you would choose, do I want the plus or do I want the minus? But this is a general solution, so we want infinite answers. We're going to leave it in there. Hold on. Go ahead.
So we're saying that E is
Yes, that's just your constant, because E is a number and C is also just a number, so the whole thing is just a number.
So how did I keep how
I just said that. I'll have a separate conversation with you when I finish, okay? It's all just a number, right? Let's try it again. How would you move this y to the left side? You would divide. So 1/y dy equals 4x to the 3rd dx. Yeah, E is a number, C is a number. The whole thing is just a number. We just call it C. All right, what is your antiderivative for 1/y? Yeah, ln, absolute value, y, equals antiderivative of 4x cubed, x to the 4th, plus c. To get rid of ln, we're going to e, or exponentiate, all right? So y equals plus minus, anyone want to give it a shot? C goes out front, e to the power x to the 4th. Good job. What's the difference with the last one? What did I throw in there? So we're not going to put a plus minus. We're going to get one single answer, okay? So divide over your y. It'll be 1/y dy. Again, I made 8, 9, and 10 all very similar, so you could kind of, do a how are these similar, how are these different kind of thing. Equals, and then on the right side, we would have 2x squared dx. Good job. Antiderivative. It'll be, again, ln y equals, and what's your antiderivative for your 2x squared? 2/3 x cubed plus c. What I get is people go and try to solve for y and then plug in the initial condition. Do not do that. You have to do these steps in order. You do the initial condition first and then all your algebra. It will turn out wrong, okay? So we're going to plug in what for x? Yeah, 0. Oftentimes it's 0, but not always. It could be whatever. So that's going to make all this go away. It'll just be C. And then on the other side, yeah, ln 3. I'm able to drop the absolute value because what's the absolute value of 3? 3. When you get to a number, you can drop it. We're going to recopy this step. Again, I always draw an arrow on it. Just recopy it exactly like it looks. Like just recopy it. But instead of plus C, we're going to put plus ln 3. Now, E and ln cancel out. Just as a heads up. Okay, so we're going to get y equals. Don't put plus and minus. You make a decision. Do we want the plus or do we want the minus? It comes from, good, that's a positive 3, so we want a plus. You don't have to write a plus. Just don't put anything. Okay. Now, out front, you would normally put C, but in this case, it's going to be 3. Here's what is going to happen. It's going to look like that, and the E and the ln cancel out. So it will be 3 e to the power that stuff. Yeah. My brain is just like that stuff, just recopy it.